factor we'll be solving for is where? Joint B. That's what we'll be solving for. That's what I want to establish. Now, you can solve for all this that equals to 0. You can do it, but then you don't just write that as if you understand that it's fixed. Do you get it now? It is different because it's one. That's why it's everything is changing. One. Yep. So it just fits. Now what's the next thing we do? So we can answer that here first. CV now becomes 1. Why? Because of this. Now let's move on. So now calculate the distribution of our. That's what we are doing. Let's go and get DFB and what? And B. We are getting DFB and DFB. Now, so let's get DFB. KBA over KBA was 8. From B, look at A, what do you have? Fixed. What's my formula for stiffness? 4EI over L. ABC. From B, look at C, what do you have? FemCD. Here is our FemCD, MCD. And our MCD, we now do what? 7.2. Yes. Now, the correction we have on our distribution table. The one we solved for was MCD, which is what? Minus 7.2. I said you should assume points. But you know that if here, normally, there is no movement at this guy, at this roller support. So the total moment you should have here should be 0. But we already said this one here is minus 7.2. So this one here should be what? 7.2. So that's why I said that MC should be what? 7.2. But we saw that's what I'm saying, that the correction we have on our distribution table. At the end of the day, I wanted to come out that what is the correction we have on our distribution table. So KBA, 4EI, now KBC should be what? What should KBC be? This is what? Age now. I mean, this is ruler age. What do you have? What do you have here? 4 over. What's the length for me? 5. So 4 over 5. What's the length for this? 4. So 3 over 4. 7.5. Abi? Now let's not get our DFB and DFS. DFB, so back to DFB. 0.8 over 0.8 plus 0.75 EI. So what do you have? 0.8 over the addition of this, what do you get? Yeah, now. Can you press calculate control? 0.5. No, now. 5. Now, EM, BC. Anything you guys tell us from here? what should we have? 0.1. So we've gotten our here. So the next thing is our distribution. Movement distribution demonstration. Having members A, B, and C. Sorry, D. Then we draw it. What am I having? A, B. We have B, we have BC, we have C, we have C, and we have BC. Next, distribution factor. What's the factor for A? 0. Distribution factor for DC, 0. Distribution factor for C, that's balance. 8 is balance. 0, which is what? 1. Distribution factor for C, this one for it. What did we get? Wait, the C. What C? Distribution factor for C. Distribution factor for C, we didn't do it. So the guys will find it. Wait, calm down. This is 0. Get 6. Eh? Calm down. Let me have an idea. Let me see. Let me see what I did. Eh? They have class by 2. Who? God be there, really ask you. So now the confusion comes down to you don't have anything like C. Exactly, that's where the confusion is coming from. It's not like this. Why? Because we don't have a support part. So the only thing we have is only C. So that's where the confusion is coming from. So the explanation system. So it is CD, that's 0. Then CD will be what? So we don't have to see. Where is it? Where is it? Where is it? So why don't we have DC? Because we don't have a support as D. So we only have what? CBC and not DC. CBC. So now these two guys are resolved. 0.5. So what we have for it here? What I have here? Minus 13.4. 9.6. Now what I have here for CD? What I have here for CD? Minus 7. You don't have to resolve for it. But that part's not part. So now the next is our first distribution. So we know that we solve an F here for CB to 13.3. Abi now. But at the end of the day, we solved again, and we said that FCD is what 7.2. So what our answer should be is 7.2. But we are having 13.3 here. So what we'll do is we'll find a value that will be subtract from this to give us 7.2. I explained why it should be 7.2 if the other one is equal to 7.2. Do you get? Because moment as an age is 0 now. So you can't have a moment as an age to be like a value. So if here is minus 7.2, you have something which is 7.2. Do you get? So this FPM is not wrong, you write it here. But but you correct this FPM to what? 7.2 at the end of the day. You don't get. So the thing is this, you can get an FPM for this, and you can get FPM for C. You have get C and C. Now, for this other part, you can get FPM for CD, because it doesn't have the support value. But you can get the moment for this particular part. And I feel that you are saying the clockwise, I'm sorry, the clockwise movement. So, this is 10 units per minute. So, if you take a moment at C, this will be clockwise, which is meant to be A times 1.2. But I said you should assume anti-clockwise. Because I said you should assume anti-clockwise for this part, so this is minus 10. So, if FCD is minus 10, FCD, the other part, the positive movement to make everything go back to zero. Because now the movement has an H. Now on your table, what you write is the MDM for C. You write it, but you make the correction that MDM for CB at the end of the day will be 7.2. So what value will I subtract from 19.3 that will give me 7.2? That's what I want to find. So 13 plus X equals to 7.2. What's the answer? 6.1, I think. So I'm subtracting what? 6.1 from it. So I won't call this the solution. What I'll call it is so what we've just done is we've corrected CD. So we call it a release CD. And the moment you do this, you make a carryover. You should have a carryover to this other one. I know the carryover happens between two supports. Distribution happens at where? At where? A joint. Carryover happens between two supports. So carryover from this guy to this guy. So I've gotten the corrected one now. So I should carry it over to this. This very is value. So carry it over to this. Carry it over to this. So what you can divide by 2. So divide this value by 2. What do you have? 3.05 minus 3.05. We are not doing all of those adding subtraction yet. So now we've done this. So the next is to now adjust our fixed length. So we did this because of the idea that this CB should be 7.2. So let's get our adjusted limit. Yeah, you have to put a value that we subtract it off. This will give us what? 7.2. And that value is what? Minus 6.1. So adjusted FPM, so what we have, this is still using whatever it is. Minus 14.4. We get what? 9.6. This minus this, minus this, minus this. So this is happening because we are having a positive value. Minus 13.3 minus. Yeah, it's minus now. Don't be minus get for this. It's minus. Minus 16 minus 1. Now just add it together. This minus this. This is 13.3 minus 6.1. That should be minus 13. This one is minus 13.3 minus 3 points. No, you are adding. You are adding right. So this was this. That's the rest. Yeah, because you are just telling fixed limit, so you have to carry whatever one you have to carry. No, only for this part. Now that this one is different, only for this part. So the moment you make a release, like you are trying to get this value should be equal to one value, you make a release, and that's it. So what do you have here? 7.2. It should be 7.2. And here it goes minus 7.2. So that means I'm not touching these two guys anymore. Why? Because I know that the moment should be what? Minus 7.2 for C and what? 7.2 for what? I'm not doing any other thing to this guy, so they are going. Every other thing that I'm doing will be for the rest of them. Because already at the end of the day, we already know that the moment at C should be what? 7.2, which will drop. The moment at this C should be what? Minus 7.2. So I don't have business with this thing and everything. So these are my things. So I'll now go distribution, the first distribution. So this is the extra step because we have an behind so the rest now becomes the same thing. So first distribution. The first distribution now. So this happens as well at the joint. If I can't do it at here, what I'm doing is these two guys, B and B. So add B and B together. You know how to do distribution now. Add it together, multiply by the distribution factor. Then get your answer. Let's why do I think? So this is 9.6 minus 16 plus what? Now multiply by the distribution factor for no, because let's do this. Multiply by the distribution factor. So you now put what? The opposite of whatever sign you have there. So the point you are getting the minus here, what's the entry of the is a positive answer? If you are getting the positive, what's the entry of the is a negative answer? So I'm having what? Minus, so you not what? Multiplying by this what you have. So I'm entering because 3.5. So this value can 0.48. Yeah, now this value is 0.48. It's meant to be a negative, but we have to enter what's the positive outside. So next is my carryover. So carryover happens with support to support, here to here, here to here. So that one is so I can't make a distribution for this guy. I told you whenever your distribution factor is 0, you don't make a solution here. So this is wrong. So carryover. Here is also dash. So 3.51 divided by 2. I carry over now. 3.51 divided by 2. 1.76. Now this here is just whatever it is. Now, can I make a carry value? No. I should, but I can't. You get why I should is that okay, because carry over goes support to support. Why I can't is because I have already calculated for the fixed end moment already. This is what the moment should be. So I won't be making any carry value. Normally, if I was to make carry value, what I would do is this is. But if I am transferring the value here, I am already changing the final answer, but I can't. That's why I have to do this immediately. So I know that I have no touching this part. You get. So I think yes. So there's a carry value. So we don't have anything else. It's not that different. So we get our final. So what's our final point? What's our final point? Add from your adjusted figure. So what you'll be adding now is from your adjusted figure. So here plus here plus minus what? This will follow. This way to be from here, we affect our every calculation. You should know that you should get the negative of this answer. If you don't, you are making this way. So here is what? 7.2 minus 7.2. So we are done with our distribution. So now we get our reactions. Same thing again. Add values of get here for us. Yeah, this is very